Okay, I didn't realize we've done most of the problem now. It says, what's the direction of his acceleration? The direction of his acceleration is upwards. We drew a force diagram. The force, we can calculate N because these are the two forces, and these two forces cause an acceleration. We can calculate what N is. N is how much the ground pushes up on him. That has to be equal to his weight, which is due to gravity. And then it also has to slow him down. So N is very large. If we were to put a scale on the ground and he lands on the scale, scales measure N. They measure the pushback. The scale actually measures what the scale pushes back on you to lift you up. And if he was to land on a scale, it would read a value much greater than just his weight. Because when he is slowing down, the scale has to support his weight, plus it has to accelerate him upwards. And N, which is what the scale would read, I'm just going to put a little note for people. Scales that you stand on display N. It's the force that they don't actually know what your real weight is. If you're standing on a scale, the scale doesn't know if someone else has their hand on your shoulder pushing you down. They don't directly calculate weight. Scales display N, the pushback from the scale on you. And if you are being lifted up by a husband who's trying to make you feel better, it will report a lower weight. If you're being pushed down upon or you jump on the scale will display values that could be greater than or less than your actual weight. So if you put the scale down, you jump on it, it's going to report a normal force is what it actually reports. You'll see it spike upwards. Anyway, the normal force that the ground exerts is equal to the guy's weight plus this force, this net force that's causing the acceleration upwards to slow him down. So that's probably part F. What's the magnitude of the reaction force? Okay, what's a reaction force? All forces come in pairs. That's Newton's third law. This force upwards of N, of the ground on the guy, is equal and opposite to a force downwards of the guy on the ground. So as much as the ground pushes up on the guy pushes downward on the ground. And if you don't think that's true, if there's some mud or some dirt, you would see the prints of the man left right in the mud. Or the ground deforms because the ground feels a downward pressure from the man on the ground. And that's equal and opposite. This is an action-reaction pair. These are equal and opposite. This force is from the man on the ground. This force is the ground onto the man.